Welcome to the deep dive. Today we're looking beyond our solar system, thinking about ringed planets.
Like Saturn, but orbiting distant stars. It's a pretty amazing image.
Absolutely. And we know there are tons of planets out there, right? Over 5,000 found since the 90s, all sorts of weird and wonderful types.
Which, well, leads to the big question. Could some of them have rings? And have we just been missing the signs?
Exactly. Feels like maybe we have. So that's our deep dive today. We're digging into some research using data from NASA's TESS mission.
Right? The Transiting Exoplanet Survey Satellite.
Our goal here is to figure out how scientists are actually looking for these, exorings and what it would mean if they found them for planet formation and all that.
Okay, let's get into it.
So, TESS, it launched back in 2018. How does it even attempt to find something like rings, which seems so subtle?
Well, TESS's main job is hunting for planets using the transit method. It stares at stars, lots of them, measuring their brightness very precisely.
And when a planet passes in front.
Exactly, a transit. It blocks a tiny bit of starlight, causing a dip in the brightness we measure. The pattern of that dip tells us about the planet, its size, its orbit.
Okay, so a standard planet transit is a fairly clean dip, but rings would change that.
That's the idea. A team led by Tsubasa Umatani in Tokyo, they took a really close look at these light curves.
What were they hoping to spot?
They figured if a planet has rims, the dip in starlight wouldn't be quite so sharp. You might see these gradual shoulders before and after the main dip as the rings start to block the light, then stop.
Ah, okay, so less of a sudden dimming, more of a gentler slope into and out of the main transit.
Pretty much, yeah. Or maybe the whole dip is wider and shallower because the rings are spread out. It's a subtle difference they were hunting for.
And they looked at a lot of planets, didn't they? This wasn't just a handful.
No, definitely not. They analyzed data for 308 exoplanets, specifically ones orbiting close to their stars. There's like 5 times more targets than previous searches focused on rings.
Wow, okay, so a much bigger net. Did they catch anything? Any clear ringed planets?
Well, they flagged 6 potential candidates. 6 systems where adding rings to the model seemed to fit the test data slightly better than just a plain planet model.
Slightly better. So not confirmed detections then?
No, not confirmed. Suggestive, maybe intriguing, but the evidence isn't strong enough to say, yes, this planet definitely has rings. It's still ambiguous.
Right. 6 hints out of over 300. Why is it so hard? Why no clear detections yet?
There are a few likely reasons. For these close-in planets they studied, any rings might be quite compact, pulled in tight by the star's gravity. Very small rings are naturally harder to see in the transit data.
Like trying to spot a tiny shadow.
Exactly. And then there's the tilts. If we happen to see the rings edge on when the planet transits, they barely block any extra light.
Ah, right. Like looking at a dinner plate from the side. Almost invisible.
Yeah. We might need to watch these systems for longer. Rings can wobble or precess in their orbits, so their tilt might change over time. More observation could catch them at a better angle.
Okay, that makes sense. Did the team put any kind of numbers on how common rings might be based on what they didn't find?
They did. For a subset of about 125 candidates, they calculated that really big, obvious rings, say, rings expanding out more than twice the planet's radius, are probably quite rare. Less than 2% maybe.
Less than 2%. So are large ring systems genuinely uncommon out there? Or is it just that our current telescopes, like TESS, aren't quite up to the job of spotting them reliably yet?
It's probably a bit of both, Our technology has limits. TESS is great, but maybe not sensitive enough for faint rings or tricky orientations. But the good news is the search isn't over.
More data coming.
Yeah. TESS is still observing in its extended mission. And looking ahead, ESA's Plato mission, launching around 2026, should have even better precision, better photometry.
So Plato might give us a clearer view. If we do eventually find confirmed exorings, what's the big payoff? What do we learn?
Oh, it would be huge. Finding rings, measuring their properties, size, density, composition, if possible, that tells you so much about that system's history.
Like how the planet formed. Or maybe collisions.
Exactly. Collisions, how moons might form around these planets, the whole dynamical evolution of the system. It adds another layer to understanding the incredible diversity of planetary systems. It would really help flesh out the picture.
It really would. This whole hunt for exorings feels like such early days, but it's exciting. Even these non-detections tell us something, right?
Absolutely. They place limits. They tell us large rings probably aren't everywhere,
Yeah.
which helps refine theories and future search strategies. Every observation adds a piece to the puzzle.
So Even though we haven't found Saturn's twin out there yet, the search goes on. And thinking about all those known worlds, the idea that some might have these incredible hidden structures, well, it's pretty mind-bending.
It definitely is, and it prompts the question, doesn't it? Given the vastness out there, what other kinds of completely unexpected things are waiting to be found just beyond what we can currently see?
A perfect thought to end on. Thanks for exploring the depths with us.